Hello everyone. Today's lesson is on systems of equations. And let's start with system of linear equations. So a set of linear equations with the same variables is called a system of linear equations. And this type of system of linear equations can have no solution, one solution, or infinite number of solutions. And this can be well illustrated when you solve for the system of linear equations by graphing, and you will be able to see how the graph of no solution, one solution, and infinite number of solutions are. So let's have the first one is intersecting lines. That means that there is exactly one solution, and the solution is the intersection of the lines. And this is consistent and independent. Another one is the coinciding lines. That means it has infinitely many solutions, and the graph would look like this. The lines coincide each other, and every point of this line is a solution to the system of equations. And we call this consistent but dependent, sorry. And then the last one is parallel lines. Parallel lines do not intersect, therefore there is no solution. That is how the graph looks like, and it is inconsistent. Now let's have some examples here. Solving linear system by graphing method. So we have the first system, y is equal to 2x, and then the second equation is x plus 2y is equal to 5. Now when you graph a linear equation, the easiest way is you assign values for your x and then solve for the value of y, or you can do the y is equal to mx plus b, where b is your y-intercept and m is your slope. You can do that as well. Or you can find the x and the y-intercept of the equation, and then you can plot it in your Cartesian plane. So that's how to graph linear equations. So let's try our first equation, which is y is equal to 2x. And then our second equation is x plus 2y is equal to 5. We will graph the first equation, but before that, we assign values for your x and y first. Okay, so you have x and you have y. So if x is -1, y is -2. If x is 0, then y is 0. Then if x is 1, then you will have y is equal to 2. And then we graph that later on. For your second equation, we have to find, okay, we use the x and the y-intercept. So we find the y-intercept. And how to find the y-intercept? You set x to 0. And then you have to find the x-intercept as well. And how to find the x-intercept? You set y to 0. So let's solve for that. We have x plus 2y. X plus 2y equals 5. So set x to 0, then you will have 2y is equal to 5. Then y is equal to 5 over 2. And that is your y-intercept. For your x-intercept, you have x plus 2y is equal to 5. Set y to 0, then x is equal to 5. Then we are ready to graph these two equations here. So you have, let's draw our Cartesian plane. So you'll have, this is your y-axis or the vertical axis, and then for your x-axis. Okay, now we do a 1:1 scale here in this graphing part. So for -1, this is 0, 0 because that is the origin. And so -1 for x, and your y is -2. So -1 here, y is -2. So it must be this point. And that is -1, -2. Then you have 0, 0. Okay, that is just the origin. That is 0, 0. And then you have 1, 2. 1, 2 is this point here. So that is 1, 2. And then let's connect the 3 points that we have. Okay. So this is the graph of y is equal to 2x. And then let's graph the second equation by the y and x intercept. We locate the y and the x intercept. So the y-intercept is 5/2, so that is just 2 1/2. 2 1/2 will be this. So that point is 0, 2 1/2. And then your x-intercept is 1, 2, 3, 4, 5. So this is your x-intercept, which is 0, 5, 0. So we connect that. Then this is now the graph of your line x plus 2y is equal to 5. So the point of intersection, the two lines intersect here. So this is your point of intersection. So this is now your solution, which is the point 1, 2. Therefore, you can say that the solution of your linear system is the ordered pair 1, 2. Then let's have the second example. You have here -9x plus 6y is equal to 12. And then the second equation is 3x minus 2y is equal to -4. So this is the first equation. This is the second equation. Then the first thing that we are going to do is, because we are going to graph the first and the second equation, we have to find, it would be easy, the very easy way to graph it is to find the x and the y-intercept. So x-intercept, or you can do first the y-intercept, it doesn't matter. So that is set y to 0. And then you find the y-intercept. And then you set x to 0. Okay? Then let's have, for our first equation, So you have negative 9x plus 6y is equal to 12. Set y to 0, so negative 9x is equal to 12. X is equal to negative 9 over 12. Or just we reduce that, that is just equal to negative 4. Sorry, that should not be, sorry, that should be 12 over 9. That should be negative 12 over 9, or that is just equal to negative 4 over 3. Sorry about that. Then let's have the y-intercept. So you have negative 9x plus 6y is equal to 12. Then set x to 0, so that becomes 6y is equal to 12. Then y is equal to 2. And then for our second equation, so we will do our second equation. You have 3x minus 2y is equal to negative 4. And then set y to 0, so that is 3x is equal to negative 4. X is equal to negative 4 over 3. And if you notice, they are the same. And then you have 3x minus 2y is equal to negative 4. Set x to 0 this time because you are getting the y-intercept. So you have negative 2y is equal to negative 4. So y is equal to 2. And if you notice, the two equations have the same x and y intercept. But actually, the first equation, if you are going to divide this by negative 3, you will be able to get 3x minus 2y is equal to 4. Actually, these two equations are equivalent equations, but I want you to see how to do the graphing method, okay? So let's graph now. Okay, let's graph our system. You have just the same. We will be doing the scale of 1 is to 1. So this is your y and this is your x-axis. Okay. Then for our first equation, let's have the x-intercept is negative 4 over 3, and that is just 1 and 1/3. So 1 and 1/3 is somewhere here. And then our y-intercept is 2, so it's somewhere here. You connect these two together to have a straight line. So this is now the graph of your equation negative 9x plus 6y equals 12. Now, what about your second equation? Actually, they are just equivalent equations, so just the same. You will have that there, y and okay. So, and this green one is the graph of your 3x minus 2y is equal to negative 4. Therefore, what can you say about our solution here? Therefore, we can say that you have the solution is infinite. It has infinitely many solutions. Then let's have solving system of linear equations by substitution. So here are the basic steps in substitution method. So the first thing is solve one for the equation for one of its variables. In other words, you can write or solve for x in terms of y, or you can solve for y in terms of x. Okay, so that is what it meant by the first step here. And then after that, you substitute what you have in A to the other equation and then solve. And then what you obtain there, you can substitute that to either of the two original equations, and then you can solve for the other variable. Now let's try to do that. Solve the linear system by substitution. So this is our first equation, y is equal to x minus 1, and the second equation is 2x plus y is equal to 5. And our first equation is already y in terms of x, so that the next thing that we will do is substitute equation 1 to equation 2. So you will have two x plus y is equal to 5. Substitute y is equal to x minus 1. So that would be 2x plus x minus 1, which is your y in the first equation, is equal to 5. Then simplify. You can combine 2x and x. So that gives you 3x minus 1 is equal to 5. 3x is equal to 6. So therefore x is equal to 2. Then you have now the value of your first variable, x, which is equal to 2. The next thing that you are going to do is substitute x is equal to 2 to equation 1. So you will have y is equal to x minus 1, and then substitute x is equal to 2. So you have y is equal to 2 minus 1, so that y is equal to 1. Therefore, you have your solution is, so you have y is equal to 1. Therefore, the solution set is the ordered pair 2, 1. Okay. Then let's have another example here. You have 2x plus y is equal to 10, and then x minus 2y is equal to negative 10. This is our first equation. This is our second equation. So the first thing that you are going to do is solve for y in terms of x for equation 1. for your equation 1. So you solve for y in terms of x for your equation 1. So you have 2x plus y is equal to 10, so that y is equal to negative 2x plus 10. And then you call this that equation 3. Okay? And then after that, the second step that you are going to do is substitute equation 3 to equation 2. So what you will have there is x minus 2y is equal to negative 10. So you substitute this, you will have x minus 2 times your y is negative 2x plus 10. So negative 2x plus 10 is equal to negative 10. Then you simplify further. You will just distribute that. So you have x plus 4x, because negative 2 times negative 2x, that gives you 4x, minus 20 is equal to negative 10. And then continue that process. So you have, okay, you have there x plus 4x, that gives you 5x, minus 20 is equal to negative 10. Therefore, 5x is equal to 10, x is equal to 2. Then you have now the value of your x. What's the next thing that you're going to do? Substitute. So the third step that you're going to do is substitute x is equal to 2 to either of the equations here. So let's just choose equation 1. Then you can have two x plus y is equal to 10. X is equal to 2, so you'll have 2 times 2 plus y is equal to 10. So that is y is equal to 6. And this is now, and you have now your solution. So that is y is equal to 6. Therefore, the solution is the ordered pair 2, 6. Then let's have solving systems of linear equation by elimination. So there are some basic steps that we need to follow to be able to solve our system here. The first one is arrange the equation with the like terms in columns. So you have to align all the x, you have to align all the y, and you have to align all the constant. It's just writing the linear equation or equations in its standard form. And then the next one is multiply one or both equations to obtain new coefficients for x or y that are opposites, okay? And then you can add the equations and solve for the remaining variable. After that, you have to substitute the variable to either of the equations, the original equations, and then solve for the other variable. Okay, let's try to apply this. It's kind of complicated when you listen and read it, but we'll try to have some examples so that we can apply all these steps in solving linear equations by elimination method. So let's have the first linear system. You have 2x minus 3y equals 13, and then negative 3x plus 2y is equal to negative 12. So you have the first equation, and this one is your second equation. So what we need to do is make our coefficients, at least for the coefficient of your x or y, must be opposites. So you have, the first thing that you are going to do is multiply. Okay, so you multiply, let's multiply equation 1 by 3, and then you multiply equation 2 by 2. So the result would be, if you multiply this by 3, then that will be 2x minus 3y is equal to 13 times 3. That gives you 6x minus 9y equals 39. And then you call this one your third equation. Okay, and then let's have the second equation. You multiply that by 2, so that is negative 3x plus 2y equals negative 12, and multiply that by 2, so you will have negative 6x, 2 times 2, that is plus 4y equals negative 24, and call that equation 4. Okay, then the next thing that you are going to do, so you will have the second step is add equation 3 and equation 4. Okay, if you add them, so that you will have 6x minus 9y is equal to 39, and then equation 4 is negative 6x plus 4y equals negative 24. So when you add this 2, you can cancel this, that is 0. So what is left is negative 5y is equal to 15. Therefore, y is equal to negative 3. And you have now value for your y, which is equal to negative 3. And then the third thing that you're going to do, so let's have the third step is you substitute y is equal to 3 to equation, any of the equations. So let's see equation 1. So you will have, what is your equation 1? 2x minus 3y is equal to 13. So that 2x minus 3 times negative 3 is equal to 13. That is 2x plus 9 is equal to 13. So continue that. You will have 2x is equal to 13 minus 9. 2x is equal to 4. So x is equal to 2. And you have now x is equal to 2. Therefore, the solution is the ordered pair to negative 3. Okay? Then let's proceed to our next example. You have here 2y is equal to 6x plus 4. And then y is equal to 3x plus 2. Now, this is by elimination method. So we'll try to eliminate one of the variables here. So this is your equation 1. This is your equation 2. And we write, the first thing that we are going to do is write the equation 1 and equation 2 in the standard form. Okay, so write equation 1 and 2 in the standard form so that your x will be aligned and your y will be aligned, so with the constants. So you will have, let's have this. Okay, so you have 2y equals 6x plus 4. Then we want y and x to the left side of your equation, so that would be negative 6x plus 2y equals 4. Okay, and then we can call this equation 3. And the next one, for your equation 2, you have y is equal to 3x plus 2. Then we want all your x and y to the left side of your equation and the constant to the right side of your equation. So we'll just have negative 3x plus y is equal to 2. And we call that equation 4. Sorry. This is equation 4. Then the next thing that you're going to do is look at equation 1, equation 3, and equation 4. So you can do the second thing here is, so step 2, multiply equation 4 by 2. Okay, so let's have, say you have equation 4 is negative 3x plus y is equal to 2. And then multiply that by 2. So you have negative 6x plus 2y equals 4. And then you call this equation equation 5. Okay. Then the third step that you're going to do is add equation 3 and equation 5, or subtract. You can subtract equation 3 and, sorry, that should be from equation 5, okay, or vice versa, it doesn't matter. Then so you have negative 6x plus 2y equals 4. Then minus equation 3 is negative 6x plus 2y equals 4. And if you notice, this will be changed, and this will be plus, minus, minus. So your answer to that, this becomes, so 0 is equal to 0. And this is a true statement. Therefore, the solution is infinite. It has infinitely many solutions. And if you notice here, our first equation, 2y is equal to 6x plus 4. If you are going to divide that by 2, it will give you y is equal to 3x plus 2. So actually, equation 1 and equation 2 are equivalent equations. That's why your solution is infinite, or infinitely many solutions. And that concludes our lesson for this week. I want you to visit the homework page of our online classroom, because you have there some exercises to answer, and you have to write that in your notebook. Thank you very much. This is your teacher, Christina. See you next week.